Professor William Stein from University of Washington. He's a mathematician in training and has done work in number theory, has been professor in the math department in the University of Washington. But I guess his passion is in CoCalc. It's a very interesting website. He will tell us about how this helps us in doing research and teaching and calculation. Thanks.
Thank you. Okay, good. So indeed, I'll be telling you about CoCalc, which is a website for collaborative calculation that makes a large amount of open source data analysis software easily available and collaborative. You can think of it kind of like taking Google Docs, where you have multiple cursors and you're editing a document, but instead of editing Word or Excel style documents, you edit more technical sort of documents, such as LaTeX documents, R worksheets, etc. And a little more, well, here's the overview of what I'll talk about. So I'll give a little more background about myself just because nobody here knows me at all. Then I'll give a demo of CoCalc, a live demo. And I'll talk a little bit about the architecture of CoCalc, a little bit about how real-time synchronization works in CoCalc and how it generates a lot of data and also provides a sort of training wheels for you or your students when you're learning new things. And go over some of the functionality of CoCalc so you can see the wide range of capabilities of this software. And finally, finish off with some of the culture of this project and the users. So a little more background. So I spent the last 6 years writing an enormous amount of code related to CoCalc, so over 12,000 commits just in this one repo that I snapshotted. So I've been doing a lot of writing of code. And then just a little more background about who I am. I started Sage Math, which is it's the biggest open source free math software package, mainly aimed at pure mathematics research and also undergraduate teaching. It's kind of like R in statistics, except unlike in statistics, there's still a pretty strong presence of commercial math software. I started it when I was here at Harvard. I was here from 2000 through 2005. And in 2004, I did a lot of research that led to starting Sage. I also started something called Cython, which is important in the Python ecosystem. It's something that takes Python and compiles it to C. So you can write very, very fast Python code. I also, as mentioned, I'm a mathematician, and I've been on leave from the University of Washington, where I'm normally a full professor for the last few years, to work full-time on building a company around CoCalc. Okay, so first I'll give you a demo. Oops. All right, so here is CoCalc. So notice the URL at the top is cocalc.com. You just go to the website, click a button to make an account, and then you're using CoCalc. It's something you can use either via the web or you can install it on your own computer. It's, the software itself is free and open source, but there's also a hosted version where you can use it for free or you can pay if you want more resources. So I'm going to make a new project inside of CoCalc. I have lots and lots of separate projects. Since I was the first person to make an account when I launched the service in 2013, I've accumulated a lot of projects over the years. So I guess I have about 500 projects that I'm a collaborator on. So I'll say demo for Big Data 2018. So I just made a new project. This project is a Docker container, or it will be hosted via a Docker container in a moment. And it's now running. I'll click on it. And there's a file system. I don't have any files yet. And I can create files in here. And I can also do calculations, run LaTeX, run R, run Sage, run Octave, whatever. So I'll just show you a few things. So you can click on this big button, create or upload files. And the first thing I'll do is I'll make has anyone here ever written a LaTeX document? Okay, well, I will do it right now. So I clicked LaTeX, What this does is it creates a new tech document. I'll show you in files. So it's file.tech, and then it should appear. There's a default template, which is a little complicated. I can say hello, or let's see, type something here. And whenever I save the file, it automatically updates the preview on the other side. So consider 2018. Which is quite a year. So I'll save, and then you'll see over here that it shows the text. So it's an online LaTeX editor. You can do some nice things like double click on one side, it takes you to the other side. It's collaborative in that if multiple people open this file, then you can see other people's cursors as they're editing, etc. Also, there's a recording of the history of all the edits that are made. So if I click this button, which is complete edit history, another tab pops up inside of CoCalc. There's a slider at the top, and you can go back and forth in time and see how the document has changed. So initially, this is the blank template where there was nothing down here. And then I started typing things, and it's all recorded via this slider. There's some interesting features. One is Sage Tech. This lets you put arbitrary computation inside of your LaTeX document. So for example, I can write, consider 2018 equals \sage factor 2018. And it will start up a computer algebra system, compute the factorization of 2018, and then fill in a nice LaTeX representation of that in the document automatically. And you can do this not only for simple things like, well, anything that Sage can do, but you can draw plots and do all kinds of complicated things. So for example, that page right there on the left has hundreds of examples of cool things you can do. But you can use all of Sage to draw 2D plots, 3D plots, etc., and they just appear automatically in your LaTeX document. There's also something very similar for R. Has anyone here ever used R? I'm just guessing because you guys are into data. Everybody's used R. So I'll make a new RTech file. This is a tech file, just like before, but you can embed R code anywhere in the file. And we'll see in a moment, it's now running knitr and then filling in the results of compiling the R code. So on the right, you have the rendered document. The left, you have the LaTeX. And yeah, so let's just to convince you of that, maybe I'll just change something here. Instead of 5, I'll put a 10 and then save it. And then what happens is it saves the file, it runs knitr, and then when knitter's done, it's going to update the preview. And now instead of 5 right there, it's a 10. And you see that there's more data. Okay? So that's the sort of thing that CoCalc gives you. It's an online collaborative LaTeX editor where you can run code in Sage and R and many other languages. And I think it's actually the only one there is that does that. Share LaTeX, which is maybe the most popular online LaTeX editor, doesn't let you run R code and Sage code and so on. And every document, you have this history of editing. There's a chat on the side, so you can type right here and go, hey, help me figure this out. And all other collaborators on the project will see that chat message, and then they can pop in and help you out. This project right now doesn't have any collaborators at all, but if I go to project settings or just click this little toggle right here, I can add collaborators to the project. So I'll do that. Oops. I'll just try to find another William out there, namely, I think there's a, let's see. I think I have another test account. So William test user. So that's another account I created. So I'll add myself as a collaborator to this project. And now I'm going to log in another browser tab to CoCalc. And then I'll see that I'm now a collaborator on that project. And then you can see that I'll be able to edit the file. This is the login screen and has single sign-on and so on. So here's demo for big data. And then here's the file we were just looking at, or the files that we were just looking at. The log shows each file that was opened and who opened it. And so here we are. And now, let's see. So maybe I'll change something here and then show you that Okay, so on the right, I'm logged in as William Test User, and on the left as my normal account. And you can see that as I move my cursor around, the other cursor moves, and you can make changes, change that to a 25, and then that changes on the other side as well. And then and whenever you save, the LaTeX gets updated. It runs R and then updates this. So in a moment, instead of 10 outputs, there's going to be 25. Maybe it has to run one more time. Or actually, sorry, RUnif was this one down here. So I changed this distribution instead. But this one up here, I'll make that 25, and then I save it. Then they run knitr, and then in a moment, you'll see 25 outputs instead. Okay, so that's it. That's one thing CoCalc does. Why this is potentially relevant to you, if you teach a class, maybe you want all the students in the class to be able to do something like a homework assignment, and they have a little bit of R code or Sage code or Python code or some sort of code that's involved in the assignment. So what you can do is put the assignment in a directory and then push it out to all of the students. They work on their assignments. As they're working, they can chat in the site if they have trouble, and you'll see a notification. So help. So what you'll see is, or your TAs, is a little notification in the top, and then you can click and it will open the file that they asked for help about. And you can see as they're working on the tech file, you'll see their cursor moving around, etc. And then at some point you can gather up all the assignments. So we have an integrated, I'm just going to open a few other types of files, and then I'll be done with the demo. So we have manage a course. So if you click here, you get our course management system. You can add a bunch of students. So I'll just make up kind of a fake one. You just paste in a list of email addresses. The students will all get projects created for them, which are brand new projects like this one, but they're empty initially. And they'll get an invitation, and then they'll join. And you can make a homework assignment. It's just an arbitrary directory of files. You can put anything you want in it, push them out to the students. Students work on them, and then you collect them. So you don't ever have to worry about uploading and downloading files or anything like that. A couple of other things. There's Jupyter Notebooks. Has anyone here heard of Jupyter Notebooks? Pretty much everybody. So these are notebooks where you edit code or Markdown. So let me edit a little bit of Markdown. This is Markdown. Maybe put some math in. I'm a number theorist, so from our cubic. And then you can, so this is so there are a whole bunch of different kernels you can use with Jupyter Notebooks and CoCalc. There's a list of them here, so you can write code in Haskell, Julia, Octave, which is like MATLAB, Python, R, Sage, etc. So I'll just leave it in Python. If you can't think of a good thing to type because you're in front of an audience or something, or you're a student, you just want to play around, there's an assistant, and you can search it, and it will show you lots of examples of various things. So let's click on bar plot. So it's an example that we can just insert in that will work, and it will give us a bar plot. So you can see how it's this sort of interactive code notebook where you type in code, you can go back and edit it at any time, and then you just do Shift-Enter, and it reevaluates the code and then shows you the output. And this is during a talk. You can type all you want, keep reevaluating. It keeps track of everything you've done. So you have this like ultimate infinite undo with attribution to who did it. And that's recorded again in this time travel. It's just like what I showed you with LaTeX, but for the Jupyter Notebook. See, so as I drag the slider, I see the different versions of the document. So I wrote this, I was teaching over and over and over again a class where I introduced the students to a whole bunch of different math or data related software and show them how to do something and then give them some challenge, and then they sit there on their laptops walking around or on their laptops trying to solve the challenge, and I would walk around and watch them work. And often what they'd do is they'd start getting something figured out and they accidentally delete it or mess it up, or they had it working fine but then they completely broke it and they couldn't get back. So with this, what happens is they just hit this time travel button, and then they get a slider and they can go back to exactly when they had the thing working, and then just copy and paste it or revert to exactly that version. It's also really important for being able to trust adding collaborators. So you can do all kinds of data analysis in these Jupyter notebooks. You might upload a whole bunch of data to a CoCalc project, and then you add some other collaborators, and one collaborator just, clobbers things or messes everything up accidentally or on purpose. And it's really nice to know that you can always just go back to a safe state. Not only can you use the slider in individual documents, but there's also file system level snapshots. These get made about every 20 minutes. And so if you have a bunch of data sitting there in your project, you can easily revert back to some previous version. So this first snapshot was made a few minutes after we started the demo, and now there are a lot more files if we were to go to the top level directory. Okay, I'll show you a Sage worksheet, and let's see, there's lots of examples here. Sage is massive, like the reference manual is well over 10,000 pages, has a huge amount of functionality, but just one random thing I see here. This makes a random walk with 1,000 steps in 3-dimensional space. So it's just stepping along. So it's generating the random walk, and then it'll draw it for us. It takes a little while the very first time you run Sage in a project, because it has to start up a backend server, which takes 5 to 10 seconds. If we ran this again, it would be almost instantaneous. But there's our 3D random walk. You can see it's just sitting there in the browser. You can rotate it around, zoom in and out, etc. Like if you want to change the color, you can change the color. We could, I don't know, make it a longer random walk, make it 5,000 steps. So that's how fast it really is normally. So it's super fast. And there you are. You can change how fast it spins when you're not touching it. Hopefully I'm not making anybody sick. Maybe I can, yeah, so. And again, this is all in a browser tab on my Chromebook. So it's just a Chromebook laptop. And so it's the sort of thing that is easily accessible to students or whatever. All you need is a good internet connection, which I have because I got an Ethernet cable here. You can also use this on an iPad and other things. And again, there's time travel, chat on the side, and so on. So for basically every kind of open source related technical data-oriented software, we've put it all in here, made it available, and there's nice support, like you click help, and you fill out a little form saying what your problem is, and then it goes to a support system. The support system, the support people, like me and the other employees of the company, can then open up exactly the document you're working with and figure out what's wrong, give you feedback, and help you out. So if you teach a class and you use this, you completely don't worry about installing software anymore. You don't worry about any technical support stuff related to software running for your students. You just, well, I mean, if something's buggy or wrong, you can just tell your students to click the help button, and then it's our responsibility. Okay, so that's the demo. And you can see I left a pile of files laying around. There's a lot of other things you can do in terms of editing files. So I should show you one or two other things. Here's a command line terminal, just to give you a sense that what's running behind this is a Linux virtual machine. Well, it's really a Linux Docker container. And I just type top, and you can see there are various processes running. And ls, you see your files. So it's just a normal computer running remotely in the cloud. Let's see, should I show you anything else? How about, there's a whole bunch of different file types that we have very good editor support for. So for example, R Markdown. So this is a Markdown editor. And on the left, you can type whatever you want. And then on the right, it will show you the resulting Markdown. You can also embed R code here, and the R code will get dynamically compiled as you go. But I can't remember a good example. So if you click in the upper right and just type something, it shows you all files that have that extension that have been recently opened. And it looks like I used R Markdown in a different project recently. So I'll just copy paste what I did there. And that way we can at least see an example that's non-trivial. So I just put that in. So this is an example, Markdown on the left, R code on the right. All right, so now that will end the demo, and I'll get back to the talk. But before I tell you more about the architecture of CoCalc, how real-time sync with multiple users works, and so on, are there any questions about what I've shown you in this demo or what CoCalc is? Yes? Yes, we do. So here I am in the editor, or any of the editors. If I go over to account settings, and then I look at editor key bindings, there are 4 options: Emacs, Standard, which is just kind of Windows basically, then Sublime, and Vim. So if I click on Vim, and then I go back here, I think I have to close and open this particular file. I'm just closing all of them. It doesn't immediately change them because you're not likely to be constantly changing your key bindings. But now I have Vim bindings. Believe it or not, I'm hitting J and K right now. And if I hit I can type. I can hit Escape or Control C. You can search, and it does Vim style search with regular expressions highlighting as you go. It's a pretty good emulation of Vim. You can do :W and it writes it to disk. And if that's not enough, you can also use the terminal. So here I am in the command line terminal. I'll open the same file and make it big enough so that you can see it. So there it is. It's the same file. This is literally exactly Vim. And so you can go in and, I don't know, I'll change the color to rainbow. I will save it. And here's some amazing magic. When I switch back to the graphical editor, it noticed that I made that change to the file on disk and did properly update it. And let's see. I think I might have to change it again to get it to regenerate this. Yeah, unfortunately. I should add a button for that. But you can edit in the terminal, and the graphical file, or the files in the graphical editor, will notice those changes and update automatically. So it's very Vim friendly and also Emacs friendly, in case that's what you use. So that's opening the same file again in Emacs. You can also SSH into any of these projects easily. So in settings, there's add an SSH key. So you just add any key from your local computer. So here's an example. I added a key to a different project, but I'm just SSHing into a different project. So it's easy to SSH into any of these if you want to use your own local, you want to sync things back and forth or whatever. Okay. Any other questions? Yes? Yeah. Okay, so there is a Docker container that we provide. So this is running on my laptop, not using the internet at all. I don't know if you can see it, but at the top it says localhost. It seems like I can't zoom in on that part of the screen, but that says localhost. We provide both the website, CoCalc.com, and then also a Docker image, which you type, let's see, it's right after, actually the thing right after the demo. If you type that line right there into, if you install Docker on your computer, which is easy on OS X, Windows, Linux, and then type that one line, then it will download CoCalc to your computer and then run it locally. And then you can use CoCalc that way. So it's not like a perfect offline mode in that you have to still synchronize your files somehow. And until very recently, one option for that was Dropbox. However, Dropbox made the idiotic decision to discontinue support for encrypted Linux file systems. So unfortunately, it's no longer possible to sync with Dropbox. But you can do that. You can also just run CoCalc locally on your computer directly rather than using Docker. Okay, so I do have great plans to make the synchronization more automatic. So use CoCalc locally on your computer, and then it'll automatically sync with some other project, but that's not implemented yet. Yep, another question? Yep.
Track changes, Microsoft Word style, is there possible to integrate?
No, the only way we track changes is we really just track all changes at it's about the 2-second level. So every change you make, the way the real-time sync works is it just creates a stream of changes and merges them all into a single log. And that change history is available to you via the slider. We intend to provide additional views of that change history, and then that would possibly look a lot more like Word's track changes. It's equivalent information. It's just that we're providing it as a slider currently. One thing we do have is a nice diff view. So you can click, you go to changes for whatever document. And if you click the changes button, you get a slider with 2 ends on it, a range slider. And you can drag either side, and it shows you the diff from one point in time to another. Okay. All right, any other questions? All right, so now I'm just going to tell you more about what's going on under the hood. So first, the tech stack. The tools that are involved in implementing CoCalc are Node.js, PostgreSQL, Python 3, React, and TypeScript. So this is a React application, and it uses some of these other technologies. Probably not so interesting to you guys if you aren't software engineers. But at JupyterCon yesterday, people are very interested in this stuff. Big data. So as people are using CoCalc, they are generating a lot of data. Every person right now who's evaluating something in a worksheet, whatever, the exact state of every document they're working with is being recorded, and that data is just there. We can use it to make CoCalc better, so we can see what sort of common error messages people have. We can see what snippets they're inserting and make those sort of more predominant and improve them, etc. So it's also a challenge. Like, people just generate an enormous amount of data in CoCalc, and we have to deal with it. So I think there have been 700,000 projects created, and there's well over a terabyte of data from these projects. I'll tell you a little tiny bit about how real-time sync works in CoCalc. It's just basically one page. So first I implemented an algorithm called differential sync by Neil Fraser. He did a master's thesis, I think, on how to do real-time sync with text, and he wrote some amazing code for computing diffs and patches between text strings. And the cool thing was he implemented this code in JavaScript, Python, and a whole bunch of other languages. He then got snatched up by Google to work on Google Docs initially and disappeared. So you don't hear from him much, but he did create this algorithm, which I implemented. I didn't really like it at all. I ran it in production for a couple of years, and it has a lot of fundamental problems. So do not implement that if you ever are implementing real-time sync. The second implementation I came up with is, and implemented in CoCalc, is much more inspired by like how multiplayer online games work and so on. But it's pretty simple to describe. Actually implementing it takes a lot of work because you have to come up with a whole bunch of little algorithms that work within the right abstractions. But the basic definitions in the algorithm are all very simple. And you can do a really, really slow, stupid implementation in about a day or even a few hours. To make it fast, though, you have to really think carefully and robust. But the basic idea is you have a patch log that is shared among all people editing a document. The patch log is just a list of triples, the time at which a change was made, the person that made the change, and what change they made. And the change is just completely arbitrary. It's just a way of transforming your document. So it's just a patch that you apply. So you have to have some way of synchronizing this log across all of the users. So when somebody makes some changes, they create a patch which describes the change they make, they send it out, and then everybody else receives it. So that's just a basic thing you have to have. And then the state of the document at any given point in time is by definition the result of applying all the patches in order. They all have a timestamp. You just put them in order, apply all the patches one after the other, and get the current version of the document. So a bunch of people are editing a document all over the place. They all take their hands away from the keyboard and stop typing. After a while, they'll all have a log of patches, and they'll order it in the same way because they all have timestamps, and then everybody will agree on the document. It's by definition the result of just running all of these patches in order. You start with the empty document and you apply patch after patch, and everybody ends up with the same document. So that's it. That's the algorithm, or at least the basic idea of the algorithm. And in practice, you have to do some sort of time synchronization, but it doesn't have to be too accurate. Like within 1 second is perfectly fine. And so you're sitting there editing. Every once in a while, when the user pauses, you make a patch from the last time you made a patch till now, and then you send that patch off. And whenever new patches come in, you apply them. Sometimes you have to stick them slightly in the past in your edit log. You apply them, and then everybody ends up agreeing on the same state. The real work goes into figuring out exactly what a document is and what type of patches are allowed. So Neil Fraser really nailed this down in the case of strings, but most interesting documents that you might work with, like Jupyter Notebooks, are not just strings. They're interesting structured documents. We have input and output, and there's dozens of messages, and you have to maintain Like you can't corrupt the document because that'll blow things up really badly. So that's how the real-time sync works. But it's just one slide, but it's, I don't know, years of pain and suffering to get it to work nicely, which it does work nicely now. Functionality, so I have only a few minutes left, but I showed you a lot of this. It's just a bunch of screenshots that kind of review what I showed you before. So I'll just go through this and shows a few things that are missing. It's a little background about browser-based code notebooks, not so relevant here. There are a couple of ways to use Jupyter in CoCalc. So I showed you a implementation of Jupyter, do this in a different order, done in React. So it's a complete new implementation of Jupyter notebooks, separate from the one that was created by the Jupyter project. And this new implementation is designed specifically for being very friendly to implementing real-time sync. The official Jupyter client is not friendly at all for real-time sync, which is why normal Jupyter doesn't provide that functionality. You have to use CoCalc to get real-time synchronization. But the ways to use Jupyter and CoCalc, one is to use our new implementation of Jupyter. You can also use just the classical normal Jupyter notebook in CoCalc. What we do is we embed it in an iframe, so it appears like it's in a tab just like anything else in CoCalc, and real-time sync does work, but the implementation of it is disturbing and terrifying if you look under the hood. What it does is it reaches into the implementation of Jupyter and changes stuff and adds a whole bunch of hooks, so that whenever you make changes, it knows about the CoCalc, which is kind of watching this Jupyter running, knows about those changes and then can properly synchronize them around. Getting that to work 99% of the time, which it does, was pretty painful. To get the last 1% really required a whole new rewrite. So the new one works 100%, I'd say, and this old one works 99% of the time, which is good for some use. But there are some extensions and features of classical Jupyter which we don't support in the new one, so it's really good to have this other option if necessary. There's also a third way. You can just click a button and just pop up a standard, completely vanilla Jupyter server in another tab running from your project. So that's like an escape hatch in case things go wrong. I'll just demo that for you. In settings, you just go down here, click plain Jupyter server, and then it takes a few seconds because it's launching Jupyter in the background, but in a moment, a new tab appears, and here's the standard Jupyter client running from the project, and you can open any of the files you would have normally opened and get the functionality Jupyter provides. So I've just opened the same notebook that we were using earlier, and this is just the plain vanilla Jupyter server. Okay, back to the talk. So there are a couple of ways to use Jupyter. There's also Sage Worksheets. Sage Worksheets are similar to Jupyter Notebooks, but it's one single document, one single editor, so you can move your cursor around easily. You can highlight just little bits of a cell and some output and cut and paste and so on. It just feels a little more natural in certain ways. A lot of things like 3D graphics tend to work better in here, and it's more optimized for using Sage. And that's just another thing that we provide. There's an IDE type mode. If you open a text file, like some code in JavaScript or Python or whatever, then there's a really nice editor with syntax highlighting, code folding, and you can split the editor in multiple points. So you can look at 15 different points in the document simultaneously if you need to. This is extremely useful when you're editing code. If you're looking at one point at the top and then you want to split it and look at a point at the bottom at the same time. And then you want to split it again and look at a third point and kind of follow a trail. By the way, the LaTeX editor works the same way. And I'll show you that because it's pretty cool. So here's the LaTeX editor again from before. And since I'm going to start splitting, whoops, crap, I just closed everything. I'll full screen it as much as possible. Get rid of the chat on the side. So you can you can get rid of the errors and warnings if you don't need them. And you can split the input. So you can look at the header of the document and at the same time look at the bottom if you need to. You can also split the preview as much as you want. So you can have like a small version of you can have a little version of the preview here. You can have a part where you're looking at maybe the references at the bottom of your paper, looking at the table of contents or something near the top, at the same time that you focus on something else. So it's really useful when you're working on scientific papers because you often are you don't want to have to flip back and forth constantly. So you can just open multiple views on the same document. You can do that systematically everywhere. Okay, moving back. Showed you that a lot. Command line, chat rooms. In addition to chatting on the side, there's full chat rooms which sort of take up the whole screen. This is a picture showing the course management system with more than one student. And this is a pretty, I don't know, mature at this point course management system. Started out just trying to solve the problem of I want to distribute assignments to my students, they work on them and I collect them. But it now does a lot more. For example, there's peer grading. There's a button you can click and after collecting an assignment, you can push it out to 3 random students. They grade it and then you collect the graded version and then you decide what the real grade is and then you push the result back to the original student. So we have stuff like that and much more. Some more examples with R. So it's drawing a graph using the R Jupyter kernel. So these Jupyter notebooks I was just showing you, I illustrated Python in them, but you can use a whole bunch of different languages, such as R, and it works very nicely for that as well. So the different ways in which you can use R in CoCalc are via Jupyter Notebook, via the command line. You just start one of these terminals and type R, and as you can see, it starts up a session there. Also, you can open a file that ends in .r, and you can edit the code with nice syntax highlighting and so on. There's R Markdown, which I was just showing you, with some interesting output, and R Tech, which I showed you a bunch. Okay, so now I'm going to finish with a remark about culture. So first, there's a bunch of people that work on CoCalc. The company has 5 people working for it, including me. And there have been many people over the years that have contributed to the code or worked on it a lot. There's investors in the company. It's a small startup company. And we have a lot of users. Most of our users are researchers or people teaching classes where they want to use Python or Sage or R in the class, and they want minimal friction. They want the students to not have to worry about installing anything unless they really want to, and they want everybody to be on an equal footing. So that's our primary use case. It's definitely used very much outside of mathematics. It's not at all restricted to math. It's also a commercial project, and it's kind of interesting why it's commercial rather than academic. So Sage, there's a lot of fairly academic projects out there, but CoCalc is commercial, and there are a couple of reasons. One is because of hosting. It's a central hosted service, and it's really hard to do that from an academic setting. So I did do that quite a bit in mathematics. I had some of the coolest online hosted compute stuff when I was here back in 2001, 2002, etc. And I then developed other stuff which I had ran at University of Washington, but periodically people would abuse the resources we made available, and then the university would just cut us off from the internet. And this just kept happening over and over again. Somebody would post something, and then it would be considered malware by some automatic scanner, and then we would get cut off from the internet. And then, we'd be gone for a day or two. And it was just pretty annoying. And there also, I ended up finally looking into legal issues because I had all this IP from new code I was writing, and I wanted to look into starting a company. And I found out that I couldn't just let arbitrary people use university resources. Because there's lots of things you can't use at a state university like University of Washington. There are lots of things you can't use university resources for. And so I ended up having to shut down running something similar to CoCalc out of the university, or the predecessor of it. So I started it as a commercial project, so you have more flexibility in how hosting works, and you get to set the rules regarding like acceptable usage and so on. So I started CoCalc as a commercial project to have the freedom from what a state university would result in, to be sustainable, and also to fund open source math software development. And also, I wanted to focus full time on developing it for a while, and any grant I was able to get wouldn't buy out my teaching, so that was kind of a problem. And I'll just finish by noting that I am still faculty at the University of Washington. I've been on unpaid leave for over 2 years, which is difficult to do in academia. Usually 2 years is the cutoff, but somehow I've made it for 2 years and about a week. So that's it. Any further questions? I've been talking for exactly 39 minutes. I think I have 40, so there's certainly room for questions if you have any more. Yes, in the back.
Is it possible to do distributed computing using CoCalc?
So his question is it possible to do distributed computing, like stuff big data people might want to do using CoCalc? And the short optimistic answer is yes. However, that's not at all our sweet spot or what we're optimizing for. So typically that's not what the people that are using CoCalc want to do. They usually want to introduce students to smaller data sets and then do assignments in class that are fairly small. CoCalc itself runs on Google Compute Engine, and Google Compute Engine has enormous resources available that we can easily spin up if necessary. There's also a lot of APIs that Google provides where you can submit, a TensorFlow model and then get back results, and they automatically deal with the scaling on the back end. But you can also easily SSH from one project to another, make a connection from one to another, but that's not what we're focused on right now. We're not focused on HPC type computing from within CoCalc. And usually if people are doing that sort of thing, they'll use a project collaboratively and then they'll SSH from their project to some other resources to launch a big calculation. So that's simply not what we're focused on at present. We have had people say, hey, I'd really like, 200 CPUs and a bunch of memory for a month with all of my students, and then we'll just spin up appropriate resources for that person. And then they'll run things however they want. Okay, any other questions? Okay, thank you.